So we're going to shift gears a little bit now. We're going to move away from the numbers and the math, and we're going to start talking about what we might normally think of as chemistry. So we're going to start, because chemistry is going to involve some changes in materials and in matter. We're going to start by talking about what matter is. And matter is just anything that occupies space and has mass. Okay? Occupies space and has mass. And for our purposes, there are three phases of matter. Okay, these are the three that we're going to focus on. We have solids, right, that we'll say have a fixed shape and volume. So when we're looking between the three phases, we'll see that there are changes in shape and or volume. So a solid has a fixed shape and a fixed volume, and you can think of anything solid, right? You can think of a block like a cube like this, or even the glass flask that cube is in, right? I can move this cube anywhere else and it will retain the shape and volume that it has here. Next we have a liquid, and liquids don't have a fixed shape, right? They just take the shape of the container that you pour them into. So here, the shape of this liquid becomes the shape of the flask itself, but it has a fixed volume, right? I might have 8 ounces of a liquid in here. I could pour it into a different container or pour it on the ground, and I would still have 8 ounces, but the shape will change based on what the liquid has been poured into. Okay. So it has kind of a variable shape, but a fixed volume. And then lastly, we have gases, and gases will always expand to fill up the container. And the gas will just expand as much as it can. So there is no fixed shape. And no fixed volume, because the volume is determined by the container that the gas is in. If I open up this flask, the gas will expand into the corners of the room. Okay. And as we're starting to talk about matter, I do want to draw a distinction between mass and weight. And this is in your book, so I'm going to go over it kind of quickly, but the idea is that mass and weight are not the same thing. We usually use the idea of weight, right? We weigh something out. And we say something weighs a certain amount. But mass is what we're going to be talking about more, and mass is different than what we think of as weight. For practical purposes, it feels like the same thing, but the way they're measured is different, and the way they're measured has to do with how balances are made versus how scales are made. So a scale you might step on to weigh yourself versus a balance that we might use in order to get the mass of something. And the distinction is just that mass is not dependent on gravitational force. So mass is independent of gravitational force. Okay, so some object will have the same mass, regardless of whether it is on Earth or on the moon or in outer space or on the space station, right? No matter where you are on the Earth. So it's independent of what that gravitational force is pulling down on that object, right? We would usually say we weigh less on the moon, and that's true because weight does depend on gravitational force. So we're going to talk about mass because mass is going to be intrinsic to a substance, right? Some object that we're looking at will have a mass, and that's going to be constant no matter who's measuring it or where they're measuring it. If we change the properties of that, maybe we cut something in half, then the mass changes. But other than that, mass is not going to be depending on where we're measuring that mass. Okay. And then lastly, I want to just mention the law of conservation of matter. We're going to start talking about chemistry and some chemical changes. And what we want to say first is that chemical changes, the changes that we're going to observe, do not create matter or destroy matter. So matter, the amount of matter, remains constant, but it may change form or may change phase, right? Solid, liquid, gas, but we're not creating matter and we're not destroying matter, though it may look like that's happening. So chemical changes don't create or destroy matter. Okay. So sometimes it may look like something's disappearing or being destroyed. Really, it's just changing phase, okay, or changing form a little bit. Okay. So we're going to move into talking about matter more and how we classify matter. I'm going to get to this flow chart at the bottom, but first we want to define some terms and start talking about what our classifications mean. And to start with, we're looking at all matter, and there are going to be two categories that we can classify all matter into, and then we're going to work our way down. And you may keep an eye on this as we go, this flow chart. But the first kind of categorization is something a mixture or is it a pure substance? That's our first step. Okay, so we will have mixtures as an option. Or if it's not a mixture, it's going to be a pure substance. Okay. And then we're going to have kind of subcategories here. So now how do we determine if something is a mixture or a pure substance? Okay. We can see if it's a mixture, it will be one of two types. So now we're going a little bit more specific. Either we can say it's homogeneous, okay, or we can say it's heterogeneous. Okay. Now, mixtures will contain more than one type of substance. Okay. Pure substances will contain only one type of substance. And that's pretty general at this point because we're going to specify what types of these we can have. What I mean by type. One type of substance. So if we have something, now I'll go back to mixtures, if we have something that has multiple types of substances in it, and we'll be able to kind of work through whether that's true or not, I'll bring up some examples. But if we have a mixture and it looks uniform to our eyes, okay, if we visually assess it and it looks like the whole sample looks uniform, then we'll say it's homogeneous. So this is going to mean a uniform composition. Okay, and so some examples of that might be coffee with cream in it. Okay, imagine black coffee and then you pour cream in it and you mix it well. The whole sample of coffee looks kind of light brown, right? There's not a region of the sample that is dark brown or a region that's light brown unless it's not mixed. Okay, so I would say maybe mixed well here, right? Milk, right? Homogenized milk would be an example of this. There's multiple substances within the milk, right? Fats and water and maybe some sugar and different things. So it's a mixture of different types of substances, but it looks all kind of milky white. Right? So it's just a visual assessment of a sample. If you look at a sample and it looks different to your eyes, right? You can look at this sample maybe of jelly beans or a chocolate chip cookie, or you can look at something and see visibly different regions where the composition is different, right? Cookie part versus chocolate in the chocolate chip cookie, or different color jelly beans, or people, right? You could look at a person and say, there's obviously, you do not look uniform, right? The hair looks different from the eyes and the feet and the skin, right? Freckles. So a heterogeneous mixture is going to show a varying composition, does not look uniform. And this can be most things, I think. This could be chocolate chip cookie. This could be salad. This could be humans, right? Anything, dogs, right? Cars. So a lot of things, maybe like mint chocolate chip ice cream, cereal, right? Anything like that. So most things, I think, are going to be heterogeneous mixtures. And again, these are if we know that there are multiple types of substances there. If we move to the other side, we've got pure substances. We say there's only one type of substance in this sample. There are also two ways to categorize pure substances, and that's either going to be, is it an element or is it a compound? So element or compound. Okay, and we're going to talk a lot about elements and a lot about compounds. So we're going to end up focusing a little bit more on the pure substance side of things for now. Elements cannot be broken down chemically. They are kind of the fundamental piece of matter, right? They can't be broken down into simpler substances by chemicals, okay, or by chemical processes. So cannot be broken down chemically. We will probably talk later on in the semester how they're broken down, but they cannot be broken down by chemical processes, chemical reactions, into smaller simpler. Lost the word for a second. Simpler substances. Okay, substances by chemical processes. Okay, and these elements are what we've collected on the periodic table. Okay, these are on the periodic table, and we're going to focus on that coming up here pretty quickly too this week probably. All right, so elements cannot be broken down into simpler substances. They are kind of the base of matter, right? They're the building blocks. Elements can be combined into what we call compounds, and compounds are still going to be a pure substance. So maybe I give you some examples of elements because I didn't do that yet. That might be like hydrogen, right? Gold is an element, oxygen. Okay, these are all the elements on the periodic table. Compounds are combinations of elements, but still what we consider to be a pure substance, right? So by definition, a compound can be broken down into elements, into simpler substances. These are our elements, but they're still pure, and this might be like water. H2O is water. It's hydrogen and oxygen, but if we have a sample of purified distilled water, the whole sample is just water, H2O. Okay. Sugar is a molecule. We'll talk about what a molecule is, but sugar is a compound. Every piece in the sample of sugar is this sugar compound. Okay, it's a pure substance. So mixtures will have multiple, might be sugar in water, right? A mixture might be these added together. That then I could separate out the sugar and the water. These would be our separate compounds, and then if I separated it into elements, I'd separate the hydrogen from the oxygen. Okay. So coffee and cream has a lot of things in it. I don't even know all of the molecules or all of the compounds that are in coffee and cream. If we were to filter it out, we could maybe get the water out, purify the coffee into water, right? Filter all of that, and then break it down into an element. So it may be, as you start out, you may have to think carefully about whether something's a compound or whether it's a mixture. But you're looking at, is everything in that sample the same thing? Is it all water? Or like over here, we've got mixtures of things. We've mixed some things together to create an even more complex sample. Okay, so we have this flow chart, and it may be helpful as you're looking at examples of classifying matter. So we're going to stop here in this video just to keep it not too long, and then we will pick back up in the next one.